Okay, so today we are going to look at density of materials. Okay, so it doesn't matter, it can be density of a stone, the density of a mango, you see, anything, density of anything, a stone, mango, orange, marbles, anything that you want to find the density for. But however, density, when you're finding the density, the formula for density, there's this triangle that you're supposed to know. Usually use this triangle. So the formula for density is equal to mass over volume. So this is the triangle that you're supposed to memorize. So from this triangle, you can extract three formulas. So density is equal to M means mass over the volume. You see, density is equal to mass on top over volume. That's the first formula you can extract from there. The second formula you can extract is for volume. You see this volume. Volume is equal to mass on top over density. So volume is equal to mass over density. The third formula you can extract from this is mass on top is equal to density times volume. You see, density times volume. But you should know the formula for density. Once you know the formula for density, you can extract all the three formulas. Okay, so since the formula is the density formula is equal to what? Mass over volume. Have you seen? So sometimes they can ask you to find the density of, for example, let's say a stone. Okay, it can be a density of a stone, for example. The first thing you do is you measure the mass of the stone using a beam balance. So a beam balance looks something like this. It has got calibrations like this. Okay, and then here on top it has got a thing that looks like this, and then it has got a stand like this. Okay, here there are numbers. It can be 10, 0, of course, 10, 20, 30, and so on. It is calibrated. So you take your stone, you put it on top here of the beam balance. This is a what? A beam balance. You're trying to measure the mass. A beam balance. So maybe when you put a stone there, the arrow move to, let's say 20. It has moved to 20 grams. So it can be 20 grams, for example. So 20 grams, that's where it has moved. But what about the volume of this stone? You see there's a stone there, you put it on top, you measure the mass is coming to 20. So you have no, the mass is 20. But how do you find the volume? You have a source of water in a measuring cylinder like this. Okay? The measuring cylinder is like this, it's calibrated. So this is 10, it goes like that. This is 20, it goes like that. This is 30, just like that. It goes like that. Maybe on top here it's 40. So the initial water, maybe it's at 15. Let's say the initial water, it's at 15 here. Before you put a stone, the water is here, it's at 15. This is water. Let's say the initial reading here, it's 15. The water level, it's at 15 cubic centimeters. That's the volume of this cylinder. So this is the cylinder. Maybe you don't know cylinder. So this is the cylinder, measuring cylinder. It measures volume. So before the water is measured, the water is at 15. Before the water is, the water level is just at 15. You put water at 15. Okay? And then after that, what do? You drop a stone in there. When you drop the stone, the water level increases. Okay? It's the same water. This is 10. This is 20. This is 30, and so on. This is 40. You remember the water level was at 15. Maybe after putting the stone in here, after you take the stone, you put it in here. You see, the stone is here now. When you drop the stone inside here, you drop the stone. The water level raises to how much? Raises to, let's say, 40. The water level raises to what? To 40 now. After I put the stone, the water level now reaches 40 now. See? My new volume, meaning my new volume is what? So the new what? The new volume or the final volume. Let's say the final volume, since that was the initial one that we had before the water, before anything entered the water. So this is now final volume after the stone was put. The final volume is now 40 cubic centimeters. You see, how do you find the density? You see, so meaning the density of this, the volume of this stone is final minus initial. So first we find the volume of the stone. So you say the volume of the stone is equal to final volume minus initial volume. Is equal to final volume minus initial volume. Okay, final volume minus initial volume. So what's the final volume? The final volume is 40. It raised, the water level reached to 40. Initial volume before the stone was put was 20. Before anything else was put was 20. So meaning the volume of the stone is 20 cubic centimeters. What about the density? Let's say now use the formula now. You see, density is equal to mass over volume. So density is equal to mass divided by the volume. What's the mass of the stone? We measured using a beam balance, it was 20 grams. Okay, over what is the volume of the stone? It is 20 as well, cubic centimeters. Why? Because the volume was the subtraction of the initial minus the final. So this will give me 1 gram per cubic centimeters. That's how you calculate density.